Random. Individual outcomes are uncertain in the short run, but there is nonetheless a regular distribution of outcomes in the long run. Probability, the proportion of time the outcome would occur in every long series of repetitions. Independence, outcome of one trial does not influence the outcome of the other event, any single outcome or set of outcomes. Sample space S, set of all possible outcomes of a random phenomenon. Multiplication principle: A times B to find the total number of outcomes must be independent. Example: 4 pairs of socks, 3 pairs of socks. 4 times 3, 12 pairs of sock combinations. Disjoint, mutually exclusive. Two events have no outcomes in common. Probability rules. Any probability is a number between 0 and 1. The second rule: all possible outcomes together must have one probability. The third rule: the probability that an outcome does not occur is 1 minus the probability that the event does occur. The fourth rule: if two events are disjoint, the probability that one or the other occurs is the sum of the individual probabilities. The fifth rule: if two events are independent, then P the probability of A and B equal the probability of A times the probability of B. Alright, so let's say we roll one dice. There are 6 possible outcomes, 1 to 6, and each of them has 1/6. Alright, so let's say we want to roll a 2 like this. It says 1/6. A 2 and a 3, 1/6 times 1/6 equals 1 over 36. Each roll of the dice is independent from all other rolls. So since they are independent from each other, we can use the multiplication roll for each trial. Alright, let's say for instance we do a probability of, let's roll a 2 to whatever number, no matter what, the number of rolls, or the multiplication will be 1/6 no matter the number of rolls. So let's say, what's the probability of rolling a 2 20 times? It'll be 1/6 to the 20. So in this simulation, we're going to flip a coin and also roll a dice. So each side of the coin, heads and tails, are both 1/2. And then for the dice, like in the previous example, it's 1/6. So let's say we flip the coin and we want to roll the dice. We get 1/2 times 1/6. Over here, it shows a 1/12 because you multiply 1/2 by 1/6 and 12, and it works the same way for tails also because of the multiplication rule. Alright, so there are 12 possible outcomes. Coin has 2 possible outcomes, the dice has 6 possible outcomes, and 6 times 2.
Demonstration, we're going to simulate replacement and non-replacement. So we have 4 different colors here: blue, red, green, and black. So let's say like the probability of selecting a blue is 1/4, and we take out the 1/4. And so we're going to find the next probability of red, but we put back the blue marker, so the probability of choosing a red is 1/4. But if we take out the blue and just keep it to the side, the probability of choosing red increases to 1/3.
And stands for and the U is for or. So the probability of A or B is the probability of A plus B minus the probability of A and B. Alright, and for this one, what's the probability of A and B? It's the probability of A times the probability of B given A. Alright, so this big square right here is the sample size, or sample space. Alright, and this is the Venn diagram. For this circle right here, it's A and B not, so A occurs but B doesn't. In this middle, A and B, both of them do occur. And then this last circle, A doesn't occur because the C means not, but it's just B occurs. And then A not and B not, none of this Venn diagram occurs out here, so these are just the people outside, or your subjects outside. And yeah, the probability of both events not occurring, the probability, to further explain A and B, so the probability of B given A is the probability of B occurring given that A has already occurred. The probability of A given B.
AP Stats class, 18 students wear Nike shoes, 6 students wear Nike shoes and shorts, 10 students wear neither. If the class has 52 students, how many students wear Nike shorts? Again, we have the notation n equals n and u equals or. So we have our sample space displayed by a Venn diagram. and basically we're trying to find this circle right here in the problem because it asks how many wear Nike shorts. So basically all you do is take the total sample size, subtract the amount that just wears shoes, and subtract the amount that doesn't wear either product, and you get 30. So 30 is the amount of students that wear only